Hi Bobcats! In this video we're going to take a formal look at ionic nomenclature. I think you'll find that all of the pieces of ionic nomenclature have been discussed in earlier videos, but now we're going to put them all together in one video to show you how to write the names and formulas for ionic compounds. Our objectives are to take the name of a compound and write the formula from the name, or to take the formula of a compound and write the name from the formula. Writing ionic names is actually a fairly simple process if you just keep one thing in mind. What we'll want to do first is write the name of the cation and then follow that up with the name of the anion. Now remember that the cation means the positive ion and the anion means the negative ion. When we write the name or the formula, the cation always comes first and the anion always comes second. When it comes to cations, we have two types of cations. There are monatomic ions and there are polyatomic ions. And the monatomic ions can be broken down further into fixed charge metals and variable charge metals. So for the fixed charge metals, which are group 1, group 2, and then those four weirdos, the diagonal rule, which is silver, zinc, cadmium, and aluminum, their charges will be the last digit of their group number, and we just call them by their name. So when aluminum forms an ion, we just call it aluminum. Then the variable charge metals are all the other metals in the periodic table, and we have to specify the charge with a Roman numeral in parentheses after the name of the element. For the positive polyatomic ions, there's only one that we're going to encounter, and it is the ammonium ion. So when you see NH4+, the name for that one is ammonium. Now there are other positive polyatomic ions, but that's the only one that you're going to run into in this course. Then once we've written down the name for the cation, all we have to do is write down the name for the anion. If it's a monatomic ion, we use the element name with the IDE ending. That's where oxygen becomes oxide, sulfur becomes sulfide, and these anions are going to be the ions formed by the nonmetals. If it's a polyatomic ion, we just use its name. So if the ion is NO3 - 1, then we just call it nitrate. Let's work through some examples. For this very first one, the formula given is CaS. It's ionic because it's a metal plus a nonmetal. When we go to look at the cation, it's a monatomic ion, calcium, and we just need to decide, is it fixed charge or is it variable charge? Calcium's in group 2, that makes it fixed charge, so we just call it calcium. We just call it by its same old element name. Now the anion is S for sulfur, and with the anions we're going to change the ending to IDE. So this becomes calcium sulfide. I'd like for you to try the next three. Pause the video, give it a go, and then come back and see how you did. All right, ladies and gentlemen, let's see what happened here. We have ZnO. So Zn is zinc. Zinc happens to be a fixed charge metal. So we just write zinc. We don't have to write any Roman numerals here. So we have zinc followed by oxygen. The anion gets the IDE ending, so oxygen becomes oxide. Next we have Cu2S, so we have copper and sulfur. Copper actually happens to be a variable charge metal, and so we are going to have to specify its charge with a Roman numeral. So let me just write copper with a blank spot in parentheses. We'll come back to that charge in just a moment. Then the S is sulfur, and we need to change the ending of that to IDE, so it will be sulfide. Now for figuring out the charge on the copper, we have to take a look at sulfur, because sulfur is always a -2. And so that means that the total positive charge in this compound has to be +2 to balance that out. But we actually have two separate copper ions, so that +2 is shared by those two ions, meaning that each one of them has a charge of just 1. So this is copper 1 sulfide. And then, let's see, last but not least, we have PbOH4. Pb is lead, and it is a variable charge metal. So once again, I'm going to put the parentheses and come back in a moment and figure out what number to put in there. The OH stands for hydroxide, and so we just name it hydroxide. So it's lead something hydroxide. Well, the hydroxide ion, if you look at a table of polyatomic ions, has a charge of -1. And the subscript of 4 means we have 4 of them, so we have -4 total. So that means the lead has to be a +4, and it's only on a single atom, so the charge is going to be 4, and so we'll write that as a Roman numeral, lead 4 hydroxide. How'd you do? I bet you did real well. Well, let's take a look at going the other way. If we're given a name, how are we going to write its formula? Well, the first thing we want to do is write down the symbol for each one of the ions, including, of course, the charge. And then if the charges cancel, we want to stop with having just one of each ion. And if the charges don't cancel, we're going to crisscross. Now, every once in a while, we're going to end up with subscripts that can be reduced. Like we're going to end up with a 2 on one of the elements and a 6 on the other element. And if that's the case, we definitely want to reduce. All right, let's take a look at some examples here. The first one says cobalt 2 bromide. So for the cobalt 2, that Roman numeral 2 is telling us that cobalt has a +2 charge. So we'll have CO with a +2. Bromide falls in the halogens, and all of the halogens have a charge of -1. +2 and -1 don't cancel out, so we're going to crisscross. We'll bring a 2 down here, we'll bring a 1 down here, and then when we clean this up and write our final answer, we do not show charges, we don't show the crisscross lines, and any subscripts of 1 we just don't write. So this becomes COBr2. Now please pause this video and work out the remaining 3, then come back and check yourself. All right, let's see how we did. Chromium 6 will be Cr with a +6. Oxide is O with a -2. The chalcogen family all go -2. +6 and -2 don't cancel, so we'll crisscross. We'll bring the 6 down here, we'll bring the 2 down here, and we will end up with Cr2O6. Now this is one of those rare times where we end up with subscripts that can be further reduced to give us an empirical formula. So let's go ahead and divide both subscripts by 2. That'll give us CrO3. That is the formula for chromium 6 oxide. For barium nitride, barium is an alkaline earth, group number 2, so it'll be a +2, it's fixed charge. Nitride comes from nitrogen, and the column that nitrogen is in is 3 columns away from the noble gases, so they'll pick up 3 electrons and have a -3 charge. +2 and -3 don't cancel, so we will crisscross, and that's going to leave us with Ba3 and 2. And last but not least, ammonium nitrate. Ammonium is that one positive polyatomic ion, NH4+. Nitrate is NO3 with a -1. +1 and -1 cancel out, so cleaning that all up, we have NH4NO3. Final answer. Our objectives for this video were to write names from formulas and formulas from names for ionic compounds.